Now that we've seen the point form of a tangent to a circle, let us now look at the second form called the slope form. So in this, what I'm doing is I'm taking a straight line whose equation is y is equal to mx plus c, and I'm taking a standard circle which is centered at origin and having a radius a. Right. Now what is the condition for this line to be a tangent to the circle? The condition is this: the c of the line, the constant, square of the constant should be equal to a square, which is this, into m square plus 1. Right. But why is this? Where is this condition coming from? It's actually coming from that quadratic that we saw a while ago. So basically x square plus y, instead of y you can just put mx plus c whole square is equal to a square. And when you expand this, 1 plus m square into x square plus 2mcx plus c square, so this is plus c square minus a square equal to 0. Now this line y is equal to mx plus c, if it is a tangent, then it is intersecting only in one point. That means this quadratic equation must have repeated roots. That means the discriminant should be equal to 0. And when you put the condition discriminant equal to 0, that is when you get this, right? So c square should be equal to a square into m square plus 1. And that means your c should be equal to plus or minus a into under root 1 plus m square, right? So when you remove the square, you'll get a plus or minus. What does this plus or minus signify? It signifies that you have a line with some slope m. Parallel to this line, there should be another tangent, right? So if I put m is equal to something, I'll have two lines plus c dash. So you'll have something like a y is equals to mx plus, instead of c, what should you have? A into under root 1 plus m square. But at the same time, you'll also have a y is equal to mx, instead of a c, you can also have a minus a into under root 1 plus m square. That's why you have a plus or minus, because with the same slope, there are two tangents possible. But how do you pick up the tangent which is passing through this point? Let this point be x1, y1, right? Let this point be x1, y1. Now this x1, y1, you'll put it in this particular line. You'll put x1, y1 in this particular line, and you'll see if it's satisfying this line or this line, right? Whichever one it satisfies, that particular tangent is the tangent that is passing through this point. So after that, it's just verification. But for writing, like if I give you a circle and I tell you that your slope is root 3, then with root 3 slope there are two tangents possible. Which are parallel to each other. That's because you have a plus and minus coming. But remember this condition. This is a very crucial condition. So a line y is equal to mx plus c, is a tangent to a circle x square plus y square equal to a square only when this condition holds good. In fact, this condition is valid for every circle. So basically, even if you have a line ax plus by plus c is equal to 0, what you will do is you will convert it into y equal to mx plus c form. You'll do it like this: y is equals to minus a by b into x minus c by a. So now your m becomes minus a by b. Your c becomes minus c by a. So still your c square, which is your c square by a square, is equals to, let the radius of the circle be r, right? It should be equal to r square into 1 plus your m square is a square by b square, right? Be it any line, pick up any line, its constant square should be equal to radius square into 1 plus slope square. This condition is will hold good for every circle and line. Like I've taken a unit circle to derive this condition, but it's valid for all circles and lines. So remember, this condition is extremely crucial. It will be really helpful during problems. Let's move on to points of contact now.